Hello, and welcome to your CNET 204 Week 3 video. This week we are going to look at the internet and web servers and how all that works. And when we get to the lab segment, we are going to spin up an Apache web server in AWS and access it through your web browser. And next week we're going to use all of this infrastructure to start building a website. Isn't that awesome? I think it's awesome. So we're going to look at what the internet is. We're going to look at some different web servers or web server software that is in use: Apache, Nginx, IIS, and there's others. We're going to look at how web servers work, so the client-server model, document route, hosting options, and URLs, and then we're going to look at the Linux segment that we need to put this together, how to access elevated privileges so you can install packages and update the operating system and manage services. And then some additional AWS networking things that we need to configure to make this work as well. We're going to modify the security group to allow inbound web traffic, and we're going to give your web server an elastic IP, which is what AWS calls a static IP, although it's more accurately a DHCP reservation. So let's start at, the beginning. What is the internet? Well, Vint Cerf, who is one of the co-creators of the internet, describes the internet as literally a network of networks. That's it. It's a network of networks that spans the globe. Now, the internet is the successor to ARPANET, which was created in the late 1960s to allow researchers remote access to computers. It's made up of interconnected networks, and it spans the globe. The internet is not owned by any individual group or country, but there's 3 organizations that exist to maintain all the standards that are used to power it. And these are the IETF, the Internet Engineering Task Force; ICANN, the Internet Corporation of Assigned Names and Numbers; and the IAB, the Internet Architecture Board. Now, the Internet is technically all of the hardware that the actual network that supports everything. Tim Berners-Lee created the World Wide Web, or WWW, in 1990, and that's made up of all the accessible web servers that exist on the Internet. Commonly nowadays, though, people tend to use the word internet to refer to both. They are technically 2 separate things, but most people, and I'm guilty of this too, just refer to the internet as what you access, not actually all the underlying infrastructure. So we're going to spin up a web server. We need to talk about web servers and popular ones that exist. Here's a list of all the popular ones, and notice there's a couple that jump out. Nginx and Apache have been jumping back and forth between number 1 and number 2 for a very, very long time. Apache has been, they've both been around for a long time, as we're going to see in a few minutes. And Apache is the web server that we are going to be configuring. It's not the most popular currently, but it is one of the most popular. And another notable one here is IIS, which is Microsoft's proprietary offering. And it's a relatively small percentage of things now, but it used to be a bit bigger. Cloudflare and Lightspeed have jumped up with the adoption of cloud-based services. So first up, Apache. Apache is the one we're going to be configuring in this course. It's a very popular web server platform. It's free, it's open source, it's available cross-platform. And it was initially released in 1995, so it's been around a long time, and it's very well documented. Apache itself was based on the NCSA HTTPD, which was based on CERN HTTPD, the original server that was created by Tim Berners-Lee in 1990 when he created the internet. It's maintained and developed by the Apache Foundation. One of the reasons that it's very, very popular is its modular nature. Its configuration is modular and can be customized with all the necessary features required to run any application. So you can enable or install different modules within Apache and customize its configuration to fit your needs. And you're going to be configuring that this week in the lab. Isn't that awesome? I think it's exciting. Now, as you saw previously, Apache, it's one of the most popular ones, but it's not the most popular one, at least at the moment. And when you're watching this, that may have changed. It might actually be the most popular one again. Nginx is also, and that's how it's pronounced, is also a popular web server that is both free and open source. It can be configured for load balancing, proxying, and caching in addition to just being a web server. And that's probably why it's so popular, because load balancing is a huge deal nowadays. It's been around since 2004, and it was released and developed by Igor Sisyev. Hopefully I pronounced his name correctly. Nginx was written with the goal of outperforming Apache. And out of the box, it does that. It uses much less memory than Apache for static files, which is what we're going to be generating mostly in this course, static web pages. And it can handle roughly 4 times as many requests per second. But this performance boost comes at the cost of decreased flexibility. So you can't, for example, override system-wide access settings on a per-file basis. Apache can do this. Nginx can't. There's a lot of things Apache can do that Nginx can't. There's also a lot of things that Nginx can do that Apache can't. Now, all web servers use the client-server model, and in fact, a lot of things that we do in networking use the client-server model. But for web servers, in particular, they use 2 ports, port 80 and port 443. And this is for web communications. Port 80 is the default port for HTTP, which is Hypertext Transfer Protocol. Stumbled over that one, I apologize. HTTP is plain text over the internet, so it's not encrypted. HTTPS, Hypertext Transfer Protocol Secure, is an extension of the HTTP protocol, and it provides encryption. It uses port 443 by default. And we're going to need to know those ports because we're going to need to modify our AWS configuration to allow traffic on those ports. When a client, which is a web browser, it could be on your phone, it could be on your tablet, it could be on a computer, when that client sends out an HTTP or an HTTP request, HTTPS request, it's sent to the server using the appropriate port. The server responds with the HTML code, which is interpreted by the browser, and you see the page that you see in the browser. We're going to learn how to write that HTML code. We're actually going to start learning how to write it next week in the lab. And that's going to be a large part of the focus of this course, with a few other languages. Really, all of these. So on the web server, there's a directory that we refer to as document root. And that's the directory on the web server where your website's files are stored and where your server serves the pages from. These files are written or can be written in a whole bunch of different languages, such as HTML5, CSS3, and PHP, HTML5 being hypertext markup language, CSS3 being cascading style sheets, version 5 and 3 respectively, and PHP stands for hypertext preprocessor. You're going to be learning all 3 of those languages in this course. Mostly HTML5 and CSS3. We're going to start learning that next week in Lab 4 and continue building on that all the way to Lab 10 and in Assignment 1 as well. And in Lab 10, you're going to get an introduction to PHP. We're just going to do a little bit with it. We're not going to do a lot because that could very well be the content of a whole another course. HTML and CSS and JavaScript, we're not doing any JavaScript in this course, but those 3 languages tend to be used for front-end web design. And PHP and other languages that you can use for this too, like Python, ASP.NET. Those tend to be referred to as back-end web development languages or back-end web development jobs, like the jobs that use those are back-end web developers. And when you get into web design, you tend to do one or the other, front-end or back-end, or you tend to try to learn everything and become what's known as a full-stack developer. And you're getting a sprinkling of everything in this course, right from configuring the server and how it works to writing and building the website using all three of these languages. So you're getting a taste of what it would be like to be a full-stack developer. And there's other languages out there that you can use. But to automate everything in the front end, it's all based on HTML5 and CSS3, so that's where we're focusing on that. And on the back end, we're learning PHP because it's the most popular, or one of the most popular languages used for that. Anyway, back to document root. The default location for document root in Apache is var www.html. It's an absolute path from root in Linux on your server. And that's exactly where you're going to be placing your website files in your server in AWS, is in that directory. Hopefully that makes sense so far. So when it comes to hosting your web server, there's a couple different ways you can do it. You can either, there are a couple different ways you can configure and host your own server. And there's advantages and disadvantages to each. Choosing the right option depends on what you need, what your requirements are, and also how much you're willing to spend. And a few other things as well, like how much space you have access to. You could deploy a website using on-premises infrastructure. And as depicted in the graph here, very minimal percentage of your costs are to deal with software licenses, and the majority of your costs are going to be configuring the hardware, buying the hardware in the first place, setting it all up, maintaining it, and also all of the things that you need for that hardware, right? You need somewhere to put it, so you need a building, you need racks, you need to power it, it needs proper cooling. This is all additional costs. And some of this is a large upfront investment, right? You have to have a building. By contrast, when you move things to the cloud, the majority of your costs become whatever your subscription fee is, because you're paying for what you use, like we learned 2 weeks ago in Introduction to AWS in the Cloud, right? And very minimal costs deal with the implementation, customization, and training. In fact, you could, in theory, do all of this for free yourself, and you're going to learn how to do that in this course. So all you have to do is pay your cloud provider whatever their monthly bill is, which, depending on what you're doing, could be a substantial amount of money. But it tends to be cheaper than having on-premises infrastructure, and that's why industry is moving this way and has been for some time. So now that we know about web servers, we know about document root, we know about different options for hosting and configuring web servers, we need to talk about how to access resources on the internet through a web browser. And that's where URLs, or Uniform Resource Locators, come in. You should already be familiar with these, because you know how to use the internet. You open a web browser, you type in google.ca, and hey, there you go, right? Or whatever website you need to go to. But URLs are a unique thing that most people don't even think about nowadays. They're one of those basic building blocks for the internet and how it works. They describe an absolute path that provides all the information about the protocol that's being used to retrieve and display the content, usually HTTP or HTTPS, though there's other protocols like FTP and Samba as well that can be accessed through a web browser. The fully qualified domain name, or FQDN, and then the path to the document on the web server, and this is relative to document root. So here's an example URL here, and this is actually the URL for the Lab 3 instructions. This first bit here, https:// that's the protocol. we're using HTTPS, which we just learned a few slides ago means this is an encrypted connection, right? Not plain text on the internet, which is what you would get if it was HTTP. cnet204.jmcarmen.tech, that's the fully qualified domain name. That's a DNS record that somebody has registered. In this case, I'm that somebody. I registered this. And then lab3.html, well, that's a web page that exists on that server. This represents the server. That's the document on the server in document root. Hopefully that makes sense. So we've talked about web servers. We've talked about popular ones, hosting options, how to access documents that are in document root and what document root is. We need to talk about the additional things we need for configuring a web server, and that's going to be more Linuxy. First up is accessing elevated privileges. Sudo or not sudo, that is the question. Shakespeare once said that, right? I don't know, that was to be or not to be. Similar though. So sudo stands for switch user do, or super user do. It was originally super user do, and it's like run as administrator in Windows. It can be configured to allow multiple users administrative access without giving anyone else the root password. And you can configure sudo to allow users to only execute specific commands with elevated privileges or root privileges. And a nice handy thing about this is any commands that are issued using sudo are logged in the system appropriately with the user that issued that command. Sorry, a dog's barking upstairs. Now to use sudo, you just put it in front of any command that you want to execute with elevated privileges and hit enter and you're good to go. You're going to be prompted for your user's password. Maybe there's ways to configure this to not prompt for a user password. And if your user has been allowed access to use sudo, the command will execute. So an example here is sudo who am I? And this is, we're going to do this when we run or use sudo in the lab, when we first use sudo in the lab. You need elevated privileges in Linux to do things like install software, to update the system, and to configure services like Apache, which we're going to do this week, right? It's a useful thing. So, to update the system in Linux or to install software, you need an active internet connection. You need to know which package management tool you're using, and you also need sudo access. You need three things there, right? Linux is interesting in that software and updates come from special sources hosted on the internet or over the internet, known as repos or repositories. All major Linux distributions host their own repo, although anybody can host a repo for a distribution, and in fact many organizations do. Due to the open source nature of Linux, certain repositories might contain specialized software that's not available in the main repo, such as EPEL, which is extra packages for enterprise Linux. They may also contain a mirror of the main repository, and this is useful just in case the main one happens to go down. To install software and updates in Ubuntu and other Debian-based distributions, we're going to use apt, which stands for the Aptitude Package Manager. So to install updates, you can issue the command sudo apt update. And you can use the optional option -y, which will auto-assume yes. Without it, you're going to be prompted whether to proceed or not. You press Y for yes or N for no. But including -y for something like that is a useful thing. When it comes to managing services in Linux, you're going to use the systemctl command, which again requires elevated privileges, or sudo. Systemctl allows you to start and stop services, as well as a variety of other things, which we're going to look at lightly in the lab. It uses the following syntax: sudo systemctl action, and then the service. Action is one of the options from the table below, which we're going to look at, And service is simply the name of the service that you're performing that action on. So the action could be start, which will start the service, stop, which will stop the service, restart, which will restart the service, status, which will display information about that service's current status, like whether it's running or not, and then finally enable and disable. Enable configures the service to start automatically on boot. Disable prevents it from starting automatically on boot. And you can see whether it's been enabled or not in the status command, or the output of the status command. So we're going to use all of those in the lab. We're also going to do a couple other things. Once we configure the server, remember we have to modify our security group because they block everything by default, right? So we're going to modify our security group to allow HTTP traffic, which we already know now is incoming traffic on port 80. And we're going to allow this from anywhere using the IPv4 anywhere IP, which is 0.0.0.0.0/0. And then finally, once we have everything running and we've confirmed it's running, we're going to change our server's configuration so that it has a static IP. Because you want to be able to reliably access this over the network or internet, and later this is going to allow us to map that to a domain name as well. Now a mechanism for this, or the mechanism for this in AWS is by assigning or associating, is the term they use, an elastic IP to your instance. This reserves a public IP from AWS's pool of public IPs and binds it to your instance. It's a lot like a DHCP reservation. Elastic IPs are interesting in that they don't cost you anything as long as the instance that they are associated with is running. When you're not using it, you get billed for it. Isn't that weird? So while your instance is offline, and yours is going to be offline for a lot of the time, or the majority of the time when you're not working on things, Amazon charges you to reserve that IP. This is going to be one of the main expenses coming out of your $100 credit that you got for free. So you're going to see that magically go up every time you log in. Don't panic. It's just your elastic IP that's costing you money. So in Lab 3, to tie all this together, we're going to create a new Ubuntu instance in AWS. We're going to use sudo. We're going to access elevated privileges. And we're going to use that to manage packages and update the system and manage services. We're going to modify our VPC security group to allow incoming traffic from anywhere on port 80. And then we're going to implement an elastic IP and bind it to our web server so it has a static IP that doesn't change. And we're going to access it through the web browser, which is pretty awesome. And by the end of this lab 3, we'll have built all the infrastructure we need to start deploying a website next week, where we're going to cover building and deploying a website in labs 4 through 10 and assignment 1. Assignment 1 is also going to layer on HTTPS. We're going to be using HTTP by default until then. And in assignment 1, you're going to register a free domain name. So until then, you're just going to have to write down this elastic IP that you assigned to the instance and make sure you look at the URL in your browser bar, make sure that it's requesting the page through HTTP or it's not going to work. That's it for the lecture. Take care, be safe, and I will see you in the Lab 3 video. Bye for now.